All right, so for our second video, we're going to take a look at another question that was on the exam. These numbers are a bit changed, so I don't remember the exact ones, but this question was pretty much on the exam. This one's notable because it's from an obscure point in the electronics unit that not much time was spent on. So it's a good example of if you want to try and figure out how to do a question that you don't necessarily remember the formula for or how to do. Because in physics, a lot of questions are really unit conversions at the core of it. And this question got a lot of people on the exam because they didn't expect something so obscure. But really, IB uses these kind of things to make sure they separate out the level 7s by putting really obscure things on it and figuring out who can either figure them out or has studied these concepts. So I thought I'd go through this as an example of how to figure out how to do a question without needing the formula and without necessarily having done it recently and knowing exactly what to do. So to start off, we have to look at what we have. So we're trying to find the drift velocity of the electrons is the important point. So how fast the electrons are going. And they've given us a current, a area, and a number of electrons per meter cubed. And you can tell that basically just by your units here. Even if you don't know necessarily what free electron density means, electrons per meter cubed tells you it's the number of electrons per unit area. And so we know we have to get there to the drift velocity. So the first thing I would look at is, again, if you know your units is the important thing for a lot of these questions. An amp is a coulomb per second. So they're telling us how much charge is passing through this wire. And if you want to convert this to electrons, which should be our goal as we're trying to figure out the speed of the electrons rather than the actual current, you look at the data booklet, and it gives us a nice figure for the charge of an electron at 1.6 times 10 to the negative 19 coulombs. So again, the data booklet has a lot of important concepts at the start that could be useful for questions, even if you don't necessarily remember. It's worth checking to find stuff like this. So if we know we have 1.6 times 10 to the negative 19 coulombs per electron, we can just reverse it to do electrons per coulomb. So if we take our 5 amps and divide by 1.6 times 10 to the negative 19 coulombs per electron, it gives us a very nice 3.1250, we'll give some unit digits for precision, times 10 to the positive 19. And then our units, you have to kind of make up electrons per second. So right away, we've looked at the units, we've pulled the number from the data booklet, and without knowing any formulas, we figured out how many electrons are traveling through this wire per second. And then the next thing, let's look at what else has been given. So the electron question is easy to imagine this as water. If you have a pipe with a certain volume of water going through it, and you know the area of that pipe, you can then break it down and figure out in each meter of a pipe how much water is in it specifically. So similarly here, if we know we have 8.5 times 10 to the 28 electrons per meter cubed, we can divide by our cross-sectional area because the area is always constant for this wire, and that'll give us the number of electrons in a meter of wire, which aids us in finding out our velocity. And that's just a simple enough multiplication calculation. If we take our 8.5 times 10 to the 28 electrons per meter cubed and multiply by 0.5, remember to convert it to meters. So in this case, we're multiplying by 10 to the negative 6 because there's 10 to the negative 3 meters in a millimeter, and it's squared this time. 10 to the negative 6 meters squared. And if you notice, meter squared, meter cubed on the bottom cancels to 3, which gives us negative 1. So in other words, as well as working out to 4.25 times 10 to the 22, we have a nice unit of electrons per meter. And so from these units they've given us, we figured out how many electrons are passing through per second. And they figured out how many electrons are in a meter. And we're looking for velocity, which is how many meters go by in a second. So with these two units, it's very easy to finally get there. There are a couple ways to do it. So either you look at unit cancellation, and if you divide electrons per second by electrons per meter, the electrons cancel out, and then the seconds to -1 divided by meters to the -1 turns into meters per second, just nicely to the 1. And you can also work it out just by thinking about it. If you have a certain amount of electrons passing by per second, and you divide that by the number of electrons per meter, you're going to get the number of meters passing by per second. So let's do that. 3.1250 times 10 to the 9 electrons per second over 4.25 times 10 to the 22 electrons per meter. And that gives us, keep in mind we only have one significant digit because of the amps, so that's just 7 times 10 to the -4 meters per second. And so we've arrived at this answer solely by working from the units they've given us and the constants in our data booklet. And so it's very possible to solve a lot of these questions without necessarily remembering exactly what you're supposed to do and what the formulas are. If you look at the units, they'll tell you a lot about what you have and what you can work with.